So what we're going to do here, guys, is I'm going to go over this activity that you were supposed to do already, and we're going to do some revisions. So what you need first is a red pen so that you can make some revisions or changes to this activity page that's already in your notebook. One of the things that we're going to be doing as we review this activity is learning how to draw force vectors. If you remember from the article, or maybe you need to go back, a vector is anything that has both size and direction. So let me give some clarity to that for those of you that were still a little bit confused. A force is a vector because it can have size, like it can be a big force, or it can be a small force. The size of the force is represented by a small arrow or a larger arrow showing, like, did I push on it really hard? Is it being pulled really hard? Or is it being pulled not as hard, indicating the size of the force? A vector is anything that has size, and then obviously every force also has a direction, like gravity might pull on an object down, or somebody might pull an object to the right, or push it to the right, but a force always has a direction. A vector can be represented by an arrow, showing whether or not that force is a large force or a small force, and which direction that force is pushing or pulling. So if we go to the activity that you guys did yesterday, we're going to be drawing some of these force vectors. Now, not only are we going to draw the force vectors that would be represented either by a large arrow or a small arrow, and then also adding a unit to it, like 100 newtons, remembering that the unit for force is newtons, or a smaller force, maybe it's, 3 newtons or something like that. But we're also going to learn to draw motion vectors. In some cases, if the forces are balanced, there will be no motion. But if the forces are unbalanced, then the object will change its motion, in which case we need to indicate a different kind of arrow to show that the object is moving. A force vector is just a single-tailed arrow, but a motion vector is represented with two tails and then the arrow showing the direction. So there is a difference between a motion vector and a force vector in the way that you draw them. So here was your first scenario in the activity that you did yesterday. You were supposed to take this character and that character, and then of course always getting the sum of the forces and the values of those forces. Both of these characters will pull on the cart with a force of 150 newtons versus 150 newtons. In this case, because those two force vectors are balanced, there will be no motion to the object. So if you need to pause this and make any adjustments with your red pen to your activity from yesterday, go ahead and do that now, showing the size of the forces with their units, and also writing down the reasoning is the cart never moved because the two forces on opposite sides were pulling with balanced forces. Now, if I reset this and I do the second scenario, which is 3 versus 1, I'm going to move any of these 3 blue characters to the left of the arrow, or to the left of the cart, and 1 red character. Doesn't matter which one. Now, you may have picked a different character, in which case your force vectors will be different. Notice that this is 300 newtons versus 150 newtons. Therefore, the sum of the force is 150 newtons. You will represent this scenario if the object will move with a double-tailed force vector arrow. I'm going to see if my computer is going to let me do this. Sorry about that. And draw a double-tailed arrow. It's not going to let me write. So this green arrow right here should be a double-tailed motion vector to show that the cart is not only being pulled with these forces, but it is actually moving with the direction of 150 newtons. This is the motion of the cart and should be represented with a two-tailed arrow. Now, why do you think that 300 newtons versus 150 newtons represents a sum of forces, or results in a sum of forces of 150 newtons? Well, it's because these two guys are going against each other. This team's going against that team, so we would subtract these two numbers in order to get the sum of those forces. Please make any adjustments that you need to. The reasoning why this cart moved to the left is because these forces are unbalanced. There was more force on the left side from the blue team than there was from the red team. Here was your third and final scenario that I said you needed to do. Move the largest blue character on the rope. Notice that these forces are unbalanced, and so this object is going to move. Watch what happens then if I click go, and then I try to balance it out. Blue still wins. Watch that again. If I put the cart in motion, then I try to balance it, nothing changes. There is no sum of forces, but there is still motion because balanced forces do not change the motion of an object. Please make this adjustment to your reasoning. Once an object is already moving, balanced forces will do nothing to change the motion. So your job today is to make any revisions to your activity and also go back to the essential question, which is, what are the effects of balanced and unbalanced forces on an object's motion? Well, we just saw it here. If the forces are, in fact, balanced, then no change in motion will occur. Meaning if it's already moving, it's going to keep moving. If it's already stopped, the balanced forces will do nothing to change the motion of an object. However, if you have unbalanced forces will change the motion of an object. It will move in the direction of the greatest force. With your red pen, please make any adjustments to your activity to answer the essential question.